Today's lesson is finding volume using discs and washers. Okay, the last lesson we did cross sections, and we worried about you'd have two curves, and that distance between them was the base of the shape, and the shape was coming out of the surface. It was perpendicular to the surface. Okay, today we're going to take a curve. Let's say my curve goes like this, and I'm going to rotate it around the x-axis so it makes a solid. Okay, if I rotate this one, when I get done, it's going to look like this. It's going to look like a Hershey Kiss. All right, so I want to find out how much volume of chocolate I need to make that Hershey Kiss. Well, if I take a cross section of this, my cross section is a circle. Okay, it's a circle or a disc. All right, so what you want to do is figure out that the area of a disc is pi r squared. And then I'm going to integrate them. I'm going to add them all up. Okay, here's just all these little itty bitty discs. So you figure out the radius, which is the distance between the curve and the axis of rotation. Okay, so these are most of the ones in this example, in this whole notes, go around the x-axis or the y-axis. They don't have to. Okay, I could have this Hershey Kiss up here like that and rotate it around 3. All right, but your radius would be the curve minus 3 instead of the curve minus 0. No big deal. All right. So it's very similar to cross sections, only we have solid discs going around every time. They're not semicircles or squares or triangles. All right, now some of these notes have been filled in by Miss Deloach just to save us time, but it gives you a picture and you see how the setup goes. We're going to work a couple of them together. And I left the answers so that I don't have to punch buttons. All right, it says find the volume of the solid of revolution generated by revolving the region bounded by the graph of y equals x cubed, the x-axis, and the lines y equals 1 and y equals 8 around the y-axis. Okay, so that's important. So you got x cubed. We're talking about the first quadrant, so it's coming up, and it goes, okay, so we have the y-axis, we have this curve, we have y equals 1, and we have y equals 8. So we're talking about this. We're going to rotate it around. It's going to look kind of like a coffee cup. Okay, so this is 1 and 8. If it's around the y-axis, you have to solve this equation for x. So you end up with x is equal to the cube root of y, or I'm going to write it as y to the 1/3. It's just easier. Okay, so this represents the radius of my circle. Remember, it's pi r squared, so I'm going to integrate from 1 to 8. The pi can go on the outside. You have y to the 1/3. That's the graph. You square it, because that's your radius. So I'm going to integrate from 1 to 8 of y to the 2/3 dy times pi. Well, you can integrate that. You add 1, so you get y to the 5/3 divided by 5/3, which is the same as multiplying by 3/5. Evaluated from 1 to 8. And you're going to multiply by pi when you're done. Let's see, the cube root of 8 is 2, and 2 to the 5th is 35. Well, let's pull this out here too. We don't need to. So then you just have y to the 5/3 evaluated from 1 and 8. Well, 8 goes in there, you get 2. The cube root of 8 is 2, to the 5th is 32. The cube root of 1 is 1, to the 5th is 1. So I end up with 31 times 3 pi over 5, which is what? 93? 93 pi over 5, which I'll put in my calculator and you get that. But this is a good answer. It's exact. Leave that. Okay, I like exact. Not bad. It says find the volume of the solid of revolution generated by revolving the region bounded by y equals the square root of 9 minus x squared in the first quadrant about the x-axis. Well, 9 squared minus x squared is a half a circle. Yeah, it's like this. Your radius is 3. But they only want the first quadrant, so all I'm worried about is this. It's already solved, so I'm going to integrate from 0 to 3, because I'm on the x-axis, I'm going that way. It wouldn't matter. Times pi. The equation's already a y equals, so it's 9 minus x squared. That's the distance from here to here. Then you square it. So now you're going to integrate from 0 to 3 of 9 minus x squared, which is pi times 9x minus x cubed over 3, evaluated from 3 and 0. You put in 3, you get pi times 27 minus 9, and you get 18 pi. Hunky-dory, man. This is the unit where I used to make bundt cakes, and I'd bring them in, and you'd all get a slice of bundt cake, and you had to figure out the volume of my bundt pan. It was so fun, because it's a rotation. Anyway, not this year. Next year. All right, rotate the region enclosed by y equals the sine of x to the 1/2. So that's the square root of the sine, right? And I said, oh, man, what's that look like? So I put it in my calculator, and I graphed it. Well, if you think about it, it's going to go like this. Then the sine's negative, so there's no answer. Then it goes like this, and there's no answer. Okay, so this is pi. Between 0 and pi. So we're rotating that right there about the x-axis. So all you do is integrate from 0 to pi the sine of x to the 1/2 squared. And I'm going to write it that way so you keep track of the fact that I'm squaring the distance because it's my radius of rotation. Okay, so now you just integrate from 0 to pi of the sine of x dx. Well, that's negative cosine, right? Negative cosine of x from 0 to pi times pi. Well, the cosine of pi is -1. You make it negative, so that's 1. The cosine at 0 is 1. So it's -1. I end up with a positive. So what did I do wrong? The cosine of 0 is 1. And then it's -1, and then you subtract a -1. That's why. Okay? Not bad. This one's interesting. Let's set it up. Find the volume of a solid revolution by generated by the region of y equals x cubed and the x-axis. So it goes like this. From -1 to 2. And I thought first I had to separate them because you have this one's down here and your top minus bottom is 0 minus the graph, and here it's the graph minus 0. But you really rotate it. But let's set it up. Let's say we have to do that. So you have pi, and you have -1 to 0, and you have 0 minus x cubed squared. And then you're going to add to it the pi from 0 to 2 of x cubed minus 0 squared. Oh, I didn't put my dx in there. Don't forget your dx. Well, if you square this, you get an x to the 6th, and that's x to the 6th. So you can just do this, -1 to 2, x to the 6th dx. And I believe that's the answer. All right? Deal. All right. There's the answer. I'm not going to do that one because we got to go on and do washers. Okay? The difference in a washer is there's a donut. You got a hole in the middle. Okay? So when you're doing your rotation, let's say I have this curve like this, and I have this curve like that, and I want the area in between them, and now I'm going to rotate it around the x-axis. Well, when I rotate it, you end up with a hole in the middle. Okay? It's like the bottom of your coffee cup got cut out. You just got a cylinder in the middle you pull out. So we're going to do the same thing we would do here. You find the area of the big one, and then you find the area of the little one, and you pull it out. So the area of the big one is the outside distance. squared minus the inside distance squared. Here it is. And be careful, it's not the same as big R for the big radius minus the little r squared. Those are not equal, okay? Common mistake. So make sure you square the big one and you square the little one. Alrighty, so let's do some of these. Find the volume of the solid revolution generated by revolving the region bound by y equals negative x plus 4. We're going around the y-axis, okay? Let's see. So it starts here. Let's see. By x equals 1. X equals 1 is here. And y equals 0. So what they're talking about is this right here. You go, well, why wasn't it this one? Well, that's not between the curve. That's the x-axis, so it's not that. Okay? Oops, sorry. So it's this shape. So it's the one I drew, only it's upside down. So here's my coffee cup going around. There's a cylinder right down the middle. I'm going around the y-axis, so I have to solve that for for x. So you get x squared equals 4 minus y, and x is equal to the square root of 4 minus y. Now my big radius is this one. So I'm going to integrate from this is 0, and that's 4. From 0 to 4. You multiply by pi. My r squared, the big R, is the square root of 4 minus y squared. And I'm going to subtract the little one. Okay, this is the short one is here, which is 1 minus 0 squared dy. So what do you get? You get from 0 to 4, this is 4 minus y minus 1. Integrate from 0 to 4 of 3 minus y. So this is 3y minus y squared over 2 from 0 to 4 times pi. I hope I get the right answer. Let's see. So you get 12 minus 16 over 2 minus 8 minus 0. I get 4 pi. Something's wrong. This is the answer I had. I trust this better. Unless I did my math wrong. That's x. So x squared is this. That's 1 squared is 1. You know, let's stick to this. We're going to cross this out. Where the heck did that come from? You get 4 pi. Somebody check that. Send me an email. Let me know what I messed up on. Find the volume of the solid revolution by revolving the region bounded by the graph of y equals 2x and y equals x squared about the line y equals negative 5. Oh, this is good. All right, the line y equals negative 5 is parallel to the x-axis. So it's the same as rotating around the x-axis. So let's draw my region. So this is down here at negative 5. My graph is y equals 2x, y equals x squared. Okay, so it's this region rotated around that. I need the intersection, so where do they meet? 2x equals x squared. So 0 equals x squared minus 2x. So it's 0 and 2. So I'm going to integrate from 0 to 2. Oh, hang on. Let's give ourselves some room to work. I'm integrating from 0 to 2. You have a pi on the outside. My big R goes from here to here. So it's 2x minus a negative 5 squared. And my little r, no, we need a new color. Hang on. My little r goes from here to here. So you're subtracting x squared minus a negative 5. Always top minus bottom. Always. All right. And then you put that in your calculator, and this is what I got for an answer. But that's the difference. top minus bottom. Guys, and on the exact same problem, if they had changed it, oh, sorry, that's not what I wanted to do. If they had changed this, and I had my shape, and it was going around +5, when you do your lines, so my big one would be 5 minus x squared, and my little one, which I didn't pink, so I'll be consistent. The little one would be 5 minus 2x squared. And I still integrate, oh, this pi's out here, 0 to 2 dx. All right, so always do top minus bottom. The negatives take care of themselves. Okay, find the volume of the solid of revolution generated by revolving the region bounded by y equals 2x, x squared, around x equals 2. So it's the same graph. Let's go back to here. Same graph. My line, my curve. X equals 2 is right here. So it's parallel to the y-axis, so I have to solve those equations for x and then do my right minus left. So the first one you get y, I'm given y equals 2x. If you solve for x, you get x equals y over 2. This one is y equals x squared, so x is equal to the square root of y. Remember, always, always, always do right minus left. Right minus left. Right minus left. Always. Okay, so now I'm integrating. I have to know that point right there. Well, x is 2, y is 4. So I'm going to integrate from 0 to 4. This is the same as rotating around the y-axis because it's a vertical line. The pi's on the outside. My big R is from 2 to this line right there. So it's 2 minus, and what did we say that was? Y over 2. And the little one is from here to here. Oh, I don't like that color. Hang on. Blech. Let's do red. Is 2 minus the square root of y squared. Okay, so this is big, little, little, right minus left, right minus left. I don't have the answer to that, so you get to look it up. Okay? Set it up, y minus, about the line 15. Let's set it up. So, this is y equals 15 is a, oh, let's not do red. It's so harsh. Okay, so we're up here. This is 15. I have 9 minus x squared. So this is 9 minus x squared is here. So that's 9. This is 3. And y equals 12. Ooh, this is interesting. So here's y equals 12. From 0 to 3. So they're talking about this area right here. It's the line y equals 15 is parallel to the x-axis, so it's the same. You're integrating in the x direction, so I'm going to integrate from 0 to 3. You have a pi on the outside. My big one is from here to here. Always top minus bottom. Don't worry about the negatives. Top minus bottom. 15 minus 9 minus x squared. Minus the little one, which is from here to here, which is 15 minus 12. And you're all done, because all you had to do is set it up. Okay, last problem here. Determine the following expression gives the volume and when it's rotated. This is the answer, okay? You figure it out. All right, practice, practice, practice. Ask me questions. That's all I got for you today.